What's up, guys? Welcome back. I just want to go over something you've probably seen before, but we're going to get into graphing systems of inequalities. But I wanted to take a day and just review graphing inequalities if you haven't seen it in a while, and just graph some basic inequalities and kind of show how it relates to like graphing an equation. What's the similarities? What's the differences? All that good stuff. So, um, if you don't remember what an inequality is, basically an inequality just uses like a greater than, less than, or equal to sign, something like that, instead of an equal sign, right? So here's an example of an inequality, right? And what this is saying is y is greater than or equal to negative 3x minus 1. What we're going to do is we're actually going to graph this inequality, okay? Now, first thing when you graph an inequality, you want to graph it just like you were graphing like a linear equation. So let's pretend that with like an equal sign. So it's like y equals negative 3x minus 1, right? So you got a slope of negative 3, you got a y-intercept of negative 1. So we should know how to graph that. We go to negative 1, we let the slope guide us. So just real quick, on your own paper, graph y equals negative 3x minus 1. Okay, so watch this. Go to negative 1, right? Put your little dot. And then you would go down 3, 1, 2, 3, right 1. Maybe do that a couple times. And get a little line going. Maybe go the other way. And we get kind of a line looking like this, right? That's the line y equals negative 3x minus 1. It's got a y-intercept of negative 1. It's got a slope of negative 3, right? So we would be done if we were graphing a line, okay? But this is not an equation. This is a inequality, right? So the only difference is this is still relating y and x, but essentially what you're doing is there's a lot of solutions to this inequality because you could find a lot of ordered pairs that would satisfy this, right? Just this side has to be bigger than that side, right? So in the equation, the line is all the set of points that satisfy the equation, right? Okay. But in an inequality, what happens is basically we're going to get a bunch of different points that satisfy this, and we're going to show kind of our audience where those points are at. Okay, so you might have seen this before. We're going to shade one of these sides rather because one side of the line is going to be solutions. The other side is going to be ordered pairs that are not solutions, right? So our job, only other job here is to figure out which side we want to shade. Okay, so just a little heads up. Usually when it's greater than like that, you're going to kind of shade like up, and you might say, well, what's really up? Well, the numbers that would put you in like the kind of almost like a positive state of mind. It doesn't really make sense, but I'll show you in a minute. But it's kind of like this way, okay? And so essentially what we're going to do is this. If you're ever confused, here's what you can do, which way to shade, okay? All you have to do is pick one point over here and one point over here, okay? One of these points is going to satisfy this and the other one is not, okay? And all we got to do is figure out which one. If we find it, we can go ahead and shade it. If we don't, we can shade the other side, okay? So I'll give you a point I always like to pick. If you can, I don't know if y'all can see this, but 0, 0 is on this side. It's on this side of the line, right? So if you put a 0, 0 in here, we're just going to ask ourselves, does this satisfy or not? And you could pick any point over here. You could pick 1, 0, you could pick 100, 100, whatever. But any point over here, you plug it in and see if it works, okay? So I like my point 0, 0 if you can use it. The only time you can't use that is when it's on the line, okay? So what I'm going to do is I'm going to put in a 0 for y and a 0 for x, okay? You would obviously put the x value where the x goes and the y value where the y goes, whatever point you pick, okay? So here's what I did. Check it out. I put a 0 in for y and a 0 in for x. Okay, now all I'm going to do is ask myself, is this true or not? Okay, so if I solve this, negative 3 times 0 is 0, 0 minus 1 is negative 1. And my statement says 0 is greater than or equal to negative 1. So I have one question for you. Is that a true statement or not? Okay, it is a true statement because 0 is greater than negative 1. So guess what? Since the point on this side of the line worked, we're going to shade everything to this side. So let me show you. Okay. I'm I'm going to shade, you see all this? I'm going to shade all this stuff, and you can kind of do it lightly with a pencil, whatever, but basically anything on this side of the line, all these numbers, the infinite coordinates, okay? Those are all solutions to this inequality, okay? Now, you notice how I put a solid line there, okay? I'll tell you more about that in a minute, but this or equal to is the reason I put the solid line. I'll talk more about it in a minute, but any point on the line actually satisfies it as well because it make it equal, okay? Here's what I want to show you though. If you'd have picked a point over here, any point over here, it would not have satisfied. So I'll give you an example. 0, 1, 2, 3, 4. I'll say 0, -5, okay? 0, -5 is like right here. Okay, you see how that's on the other side of the line, right? If you'd have put in a 0, -5, you put in a 0 for x and a -5 in for y like that, watch what happens. You get -5 is greater than equal to -1 like that, see? And that is obviously not true, right? So I'm here to tell you, one side of the line is going to work and the other side's not in inequality. So all you have to do is figure out which one works and then shade that side of the line. So the graph would look like this. It would be a solid line right here, and then it'd be all this stuff shaded. That's the graph for this inequality. You have to have this stuff shaded because you're telling the people, hey, listen, all these points are valid solutions to this inequality. Okay, so I'm gonna do one more example where you make sure you get this. And I'm going to throw some stuff at you here that maybe you forgot about, but let's look at this next example. It says 2x minus 4y is greater than 8. So here's the next one right here, right? We're going to graph it. So first thing we want to do is we want to isolate that y because you kind of want it like y equals mx plus b. So here's what you should do, okay? If you want to isolate that y, I'm going to subtract the 2x over first. So if you subtract the 2x from both sides, you get -4y is greater than -2x plus 8. And then what you want to do is you want to divide by -4, okay? So you divide by -4, everything by -4. -4 divided by -4 is just 1, so we have y, right? Over here, -2 divided by -4 would be 1/2, so you have 1/2 x. And then 8 divided by -4 is -2. Now, notice I left that inequality part blank, the greater than sign, okay? Now, here's one of the reasons I did this problem. If you ever divide or multiply by a negative number on both sides, I don't know if you guys remember this, but you actually have to switch the sign, okay? So you see how it was greater than, now it's less than, okay? So basically, this is what we're going to be graphing, okay? Remember that if you ever divide or multiply everything by negative, you have to flip the sign on the inequality. So it was greater than, now it's less than, okay? So this is what we're going to try and graph. Y is less than 1/2 x minus 2, okay? So here's what we're going to do, okay? We're going to graph this like it's a normal line. So what's the y-intercept? -2, right? And what's the slope? 1/2. So watch this. You go down to -2, you put a dot. Then you go up 1, right 2. So up 1, right 2, put a dot. Do it again. Up 1, right 2, you put a dot, and you have your little line forming, right? Now, notice what I'm going to do here. You notice anything different about that line? I made it just a dotted line, okay? Now here's why it's just a dotted line. You see this sign right here? It was just less than, right? If it's just less than or greater than, it has to be a dotted line because basically the points on the line make it equal, right? If it doesn't say or equal, the points on the line actually don't work, okay? So if you ever see just a straight up one like this, make it dotted because what you're telling the audience is, hey, look, I know I have this line here, but the points on the line do not satisfy this inequality, okay? So there you have it, right? And now all we have to do is pick one side or the other to shade, okay? Now, I'll give you an example. Okay, you see that 0, 0 right there? 0, 0 is on this side of the line, right? You don't have to pick that. You pick any point you want that's not on the line, right? But I'm just going to pick 0, 0 because it's very easy for me to do, okay? Now, if I put in 0, 0, to this inequality. I put a 0 in for y and a 0 in for x, like this. All we have to say is this true or is it false? Okay, so let's simplify. Okay, so 0 is less 0 minus 2 is -2. Is that a true or false statement at the bottom? 0 is less than -2. That's false, right? Because 0 is actually greater than -2. It's confusing, but 0 is greater. Okay, so look, when you say if this is false, here's what that means. Okay, if that's false, you don't shade the side with 0, 0 on it, right? You shade the other side. Okay, and if you picked any point over here, any point you want, it would have came out to be true. So here's what you do: you shade all of this stuff with your pencil or pen or whatever, right? And that is your graph. It's that dotted line with the shaded region. And that shaded region represents every single ordered pair that would satisfy this inequality. Okay, so hopefully that knocks some cobwebs off for you. And we're going to be putting these things together with other ones tomorrow. But for tonight, all you have to do is graph inequalities. Okay, so I hope that made sense. If not, shoot me some questions. But I'm glad to be getting into to some new material, and I'll talk to you all tomorrow. See ya.